In number 7, we want to evaluate some definite integrals. All right, so we have the integral from 0 to pi over 2 of sine x dx. All right, well, the derivative of cosine is minus sine, so the derivative of minus cosine is sine. So this integral is minus cosine x, evaluated between 0 and pi over 2. So now we just substitute in minus cosine pi over 2, subtract minus cosine 0. Let's just remember what the cosine curve looks like so that we can recall these values. Here's cosine between 0 and 2 pi. All right, so that's pi. This is pi over 2. So we see that cosine pi over 2 is 0. And cosine 0 we see is 1. So this whole thing is equal to 1. In part B, we have the integral of 2x squared minus 5x between 0 and 1. So let's just use the power rule here. Integrate 2x squared, that would be 2x cubed over 3, minus 5x squared over 2. And we're going to evaluate this between 0 and 1. Substitute in 1 and we have 2/3 minus 5/2. And we substitute in 0 and we have 0. So we just have 2/3 minus 5/2. I'll just combine these. All right, common denominator 6. So that would be minus 11 over 6. Number 8, we want to find the area between y equal minus x squared plus 4x and the x-axis. This is a parabola that faces down, so the basic picture would look like this. If that's the x-axis, we have this parabola, and we want to get the area between the two x-intercepts. That's the x-axis. All right, so what we want to find is, first of all, those two x-intercepts, so we'll set this equal to 0. Factor out an x. And set each factor equal to 0, and we have x equals 0, x equals 4. So we're going to integrate from 0 to 4. That's equal to minus x cubed over 3 plus 4x squared over 2. All right, let's just substitute in here. All right, let me reduce that. That's a 2. So we have minus 4 cubed over 3 plus 2 times 4 squared. All right, that's minus 64 over 3 plus 2 times 16 plus 32. Okay, we'll just get a common denominator. and we have 32 over 3. In number 9, we want to find the average of this function, y equals 3x squared plus 1, on interval 1, 3. So let's remember our formula. The average of f of x on AB is equal to 1 over b minus a times the integral of f of x from a to b. All right, so let's do this little calculation. So here we have 1 over 3 minus 1, and we're integrating from 1 to 3, 3x squared plus 1 dx. Okay, so we have a 1/2 on the outside. And here we have 3x cubed over 3 plus x. All right, so that's equal to, here we have 3 cubed 27 plus 3 and then here substitute in 1 and we have 1 plus 1. All right, so this comes out to 1/2 times 29 minus 2, 1/2 times 27, or 27 over 2. In 10a, we're applying the second part of the fundamental theorem of calculus. So let me just remind you of that. Okay, the second part says that the derivative of the integral from a to x of f of t dt is equal to f of x. All right, so in part A, we simply have the derivative with respect to x of 1 over x sine t dt. All right, that's simply equal to sine x. Okay, let's look at part B. So in part B, we're going to do something similar. Let me rewrite this. Okay, here we're going to replace t with this x squared. And then multiply by the derivative of x squared. That's a chain rule. So we have here x to the 6th times 2x, or 2x to the 7th. In number 11, we're just finding this limit, and we're going to base this on the following. The limit, this we saw in class, as x goes to 0, of sine x over x is equal to 1. All right, so in this case, we have sine 5x over x. So if we could replace that x in the denominator with 5x, this limit goes to 1. So let's compensate for putting an x in the denominator. Let's multiply by 5. So we say that this goes to 1. So the whole limit goes to 5.